Here is the solution of a particular physics problem given in one of the most famous books to learn physics. And here is the exact same solution which you can do from my method, which I'm going to teach in this particular video. So, hello guys, welcome to my YouTube channel. When I was in 11th, 12th, even I used to refer this book and I used to solve this lengthy solution every single time, which used to take a lot of time to solve, and is also a very tedious task, especially if you want to do in competitive exams where you have to solve a particular problem in 1 minute. So here is the exact same solution which I came to know that this particular problem could be solved such easily also. So in this video we're going to be discussing about resolution of vectors. This is the part 2 of vector series. The part 1 of this particular series will be linked down below. You can go and watch it. So without wasting any time, let's get started. So resolution of vectors is taking a vector and splitting into 3 particular components along x, y and z axis, and if you add those 3 components, you're going to get your vector back. So this is how resolution of vector works. So now let us see resolution of vectors along 2 dimensions. So imagine you have a vector. Suppose this is vector A. So this is vector A. So I take Cartesian planes. So as you know, Cartesian plane is representing something in the form of xy axis. So this is your Cartesian plane. So you have x axis and y axis, and you have taken the tail of this particular vector to the origin. Now if I drop a perpendicular from tip of the vector A to the base, which is along the x-axis, and do the same along the y-axis, and let's say the angle of this particular thing is theta. So if I apply the sine theta, so sine theta, which is opposite by hypotenuse, so opposite is this particular length. Let me take it as ay because this is along y-axis, and this I'm going to take it as ax, and the length of this particular thing, which is magnitude. I told you length of a particular vector is said to be its magnitude. So the length of this particular vector is going to be my magnitude of a, or simply a. So this is my opposite side, opposite to the theta. So this is my adjacent side, and this is my hypotenuse. So sine theta equal to opposite by hypotenuse. So opposite is equal to ay. Remember ay because this coincides with this, and this is along y-axis, so that's why I wrote it as ay. Whereas this is along x-axis, so that's why I wrote it as ax. So ay divided by hypotenuse is a. So ay divided by a equal to sine theta, and if I do the math, so a sine theta is equals to ay. So this is a very important conclusion. So I'm going to write it over here. So ay equal to a into sine theta. So similarly, if I do cos theta, so cos theta equal to adjacent by hypotenuse. So cos theta equal to adjacent side is this ax divided by hypotenuse is a, and ax is going to be my a into cos theta. Same math. So I got my ax value as a into cos theta. So ax equal to a into cos theta. Remember, a is equal to magnitude of a, or simply I can write it as a to avoid writing it every single time. So this was my particular conclusion. Now what I can say is, so what I can do from unit vector means, so as you know, vector could be written in the form of combination of both its magnitude as well as direction using unit vectors. So suppose I have vector a. I know it is made up of 2 things, which is magnitude and as well as direction. So this is my magnitude, whereas this is my direction, and this is called unit vector, which represents the direction, whereas this is my magnitude. So vector is a thing which has both magnitude as well as direction. So this is my usual unit vector concept. So applying the same particular concept of unit vectors for vectors along ax and ay, I can come into conclusion that, so ax vector is going to be my magnitude of ax into ax cap. This represents the direction, this represents the magnitude. So ax magnitude is a into cos theta. So magnitude of ax is, or simply ax into ax cap, whereas ax is equal to a into cos theta. Whereas what is ax cap? Ax cap is I cap. So I cap is the unit vector unit vector along x-axis. So if I say I cap, it means vector is represented along x-axis. So similarly, if I say j cap, it means represented along y-axis. If I say k cap, it is represented along z-axis. So I'm going to write that also. So for so this is my ax vector. So similarly for my ay vector is going to be my a into sine theta. So ay into ay cap. So ay is a into sine theta, whereas ay cap is equal to j cap. So j cap means vector is, if a vector is directed towards y axis, it is called j cap. Similarly, if I write it in the form of 3 dimensions, so z cap, which is along z axis, so a sine theta into k cap. So I cap means along x axis, j cap means along y axis, k cap means along z axis. Now since we don't have along 3 dimensions, I'm going to erase this. So for this particular vector a could be represented as a vector is equal to ax vector plus ay vector. I'm going to erase this and write it very neatly. So everything is a bit neatly written over here. So let me write it separately again. So as I told you, resolution of vector means writing a vector as the sum of other vectors along x, y and z axis. In this case, we have only x and y axis. So a vector is equal to ax vector plus ay vector. You can apply a triangular law of vector addition over here. So ax plus ay is going to be give your a vector back. So from the previous thing which I did back, so ax is a into cos theta I cap, whereas ay is a into sin theta j cap. So always remember, ax means cos theta, ax means a into cos theta, ay means a into sin theta. You have to like remember this no matter how much time it takes. So make sure you remember this. So a into cos theta means along x-axis, a into sin theta means along y-axis, whereas I cap means x-axis, whereas j cap means y-axis, and k cap means along z-axis. So always remember, I cap means vector is directed towards x-axis, j cap means vector is directed towards y-axis, k cap means vector is directed towards z-axis. So combination of these two vectors gives you a vector. Also, what we can do from this is we can find the length of a, which is magnitude of a. So magnitude of a, or simply a, is equal to square root of, so as you can see, this is the hypotenuse and these are the two sides. Using Pythagoras theorem, you can say that. So I'm gonna take this triangle over here. So this is my theta and this is a, this is ay and this is ax. So a is a square equal to ay square plus ax square, and a equal to square root of ay square plus ax square. So from this conclusion I can write over here, magnitude of a will be equal to square root of ax square plus ay square, or simply I can say a square cos square theta plus a square sin square theta, or a square root of cos square theta plus sin square theta. I'm gonna get my a into 1, which is equal to a. So from this I can prove that magnitude of a is equal to root of ax square plus ay square. So this is a very important formula which you have to remember in order to find the magnitude of a particular vector. Okay, now let us see how we can resolve vectors in 3 dimensions. So it's a quite simple thing. So I'm going to write the 3D axes over here. So this is my x-axis, this is my y-axis, and z-axis is going to be like this. Since I can't write it in the plane, I'm going to write in this form. So the z-axis is out of the plane. I'm writing in this way. So my vector is going to be my a vector, and the, so again I'm going to drop the perpendiculars. Perpendicular has been dropped on the x, y and z axis respectively, and the component along x axis will be written in the form of ax vector, component along y axis ay vector, component along z axis az vector. So from this I can write a vector is equal to, so a vector equal to ax vector plus ay vector plus az vector. Applying unit vector concept, I can write, so a vector equal to ax into ax cap plus ay into ay cap plus az into az cap. So as I told you, unit vectors along x, y, z axis are equal to I cap, j cap and k cap respectively. I can replace this with izk respectively. So I'm going to write it over here. For x, y and z axis, you have to write I cap. For this you have to write j cap, and for this you have to replace it with k cap. So I'm going to replace there. So ax I cap plus ay j cap plus az k cap. So this is my a vector. I have represented in the form of sum of these particular three vectors, which is called the resolution of vectors. This is the overall three-dimensional thing. So if the z-axis is zero, this is going to turn into your two-dimensional thing. So if you learn three-dimension, it's like learning with two-dimension also. So j cap plus az k cap. So this is an important conclusion. And the length of this particular vector is going to be, so a vector magnitude, which is equal to a, is going to be square root of ax square plus ay square plus az square. So this is also a very important conclusion. You can use geometry to prove this particular thing, which comes in three-dimensional geometry. I'm not going to do that, but for now. So from this, you can also conclude that if your z-axis is 0, this is again going to turn into your two-dimensional thing. So if you have 3D, just another component is going to come and add there, which is called az square. Okay, now let us see the operations of vectors. So operations like addition, subtraction, differentiation, integration, all these four operations could be done on components of vectors. So let us discuss everything in detail in this particular thing. Whereas multiplication of vector involves a particularly different concept, which I'm going to teach in the third part of this particular series. So now let us see the addition first. So addition and subtraction. Addition and subtraction. So suppose you have two vectors. So a vector is equal to ax, I'm going to take it as ax I cap plus ay j cap plus az k cap, whereas b vector, that would be bx I cap plus by j cap plus bz k cap. So suppose if they ask me to add these two particular vectors, so if they ask a plus b vector, I just have to add their respective components. So ax plus bx whole I cap plus ay plus by plus by whole j cap plus az plus bz whole k cap. Now what if they ask subtraction? So what if they ask a minus b? Remember, the order must be a plus b only. You should not shuffle them. If you shuffle them, you're going to get a different answer. Whereas for this, it's going to be ax minus bx. So just respectively add or subtract the particular components. So in this case, it is going to be like this. So ay minus by j cap plus az minus bz into k cap. So these were the addition and subtraction of components of vectors. Now let us see the integration and differentiation. So so the concept of integration and differentiation will be discussed in a separate video. Just for now, remember that these two are two particular operations which you can do on equations, just like addition and subtraction. So suppose I have a displacement vector d. So d vector equal to dx I cap dy j cap plus dz k cap. So since you know that differentiation of displacement vector with respect to time is going to give your velocity vector. So in this particular scenario, my d vector is equal to this. So I'm going to replace d vector with all this components, dy j cap plus dz k cap whole by dt. So individually I can separate them. So dx by dt I cap plus dy by dt j cap plus dz by dt k cap. So I have separately taken the operation and distributed to every single components. So what I can do, I can just perform the differentiation operation. So dx by dt, so d of dx by dt is going to be q my vx I cap, similarly vy j cap, similarly vz k cap. So this is going to be my velocity vector. And since you know differentiation of velocity vector differentiation of velocity vector is going to give your acceleration vector. I can also differentiate this particular whole equation just like I did for displacement, and I can conclude that my acceleration vector is going to be my, so d vx by dt I cap plus d vy dt j cap plus d vz by dt k cap. So differentiating all this, I'm going to get my answer as ax I cap plus ay j cap plus az k cap. So this is the operation of differentiation. Now if you integrate this particular equation, so integration of this with respect to time, I'm going to do the reverse. So if you don't know differentiation and integration, you can't understand this. So I hope you have a little bit of basics here. So suppose I take acceleration vector to difference, integrating it with respect to time. So acceleration equation is, so ax I cap ay j cap plus az k cap. So I'm going to replace this with this. So ax ay plus az k cap whole with respect to dt. So integrating this, I'm going to get as integration ax I cap dt plus integration of ay j cap dt plus integration of az k cap with respect to dt. So integration of acceleration with respect to time is going to give your velocity. So vx I cap plus vy j cap plus vz k cap, and this is going to give your velocity vector. So I can perform integration, differentiation, addition, subtraction. So I can perform multiple operations on components of vectors. So it's a very important concept which you need to know. Okay, now let us see the equality of two vectors. Since you know vector is made up of two particular things, which is magnitude as well as direction. Two vectors are said to be equal if they have both magnitude as well as direction to be exactly same. So suppose a vector is equal to b vector, which means magnitude of this vector is equal to magnitude of this vector, whereas direction also are exactly equal. So two vectors are said to be equal if they have both magnitude as well as direction same. Now suppose a vector is ax I cap ay j cap plus az k cap, as I did previously. So bx I cap plus by j cap plus bz k cap. So this is the representation of vectors in the form of components. So if, since these two are equal, their particular components are also said to be equal. So this will be equal to this will be equal to this, whereas this will be equal to this. So from this I can say that ax equal to bx, ay is equal to by, az is equals to bz. So this is the conclusion which I can draw if two vectors are said to be equal. So now let us see the parallel vectors. So two vectors are said to be parallel if they have same direction, but different magnitude. For example, I can write like this. This is a vector A and this is vector B, almost in the same direction. So these two vectors have same direction but different magnitude. So I can say these two particular vectors are parallel to each other. Now suppose a vector equal to, so a vector equal to ax I cap plus ay j cap plus az k cap, whereas b vector is equal to bx I cap plus by j cap plus bz k cap. From geometry I can conclude that these two components, the components of these two particular vectors are related by ax by bx is equals to ay by by, that is equals to az by bz. So if I say two particular vectors are parallel to each other, then I can conclude that their particular components have same ratio. So this and this all are equal. So this is the conclusion which I can draw from parallel vectors. Okay, now let us see some must know values of trigonometric functions and particular tricks I can say in order to solve problems. So now suppose you have a, this is your a vector. Now if I want to resolve that into two vectors which is along x axis and y axis, I'm going to do it as in this way. So ax ay, I'm not going to write all the this x-axis and y-axis things. So simply you have to write ax and ay. And if this is a theta, always remember ax value will always be equal to a into cos theta, where a is magnitude of a. Ax will always be equal to cos theta. So ax relates to cos theta, so a into cos theta, whereas ay will always be equal to a into sin theta. So the perpendicular thing which is towards the top, which is along the y-axis, is always going to be your a into sin theta, whereas which is towards the horizontal always is going to be your a cos theta. So horizontal component is a cos theta, whereas vertical component is always going to be your a into sin theta, whereas theta is the angle between x-axis and vector. Now some trigonometric values which you need to be knowing is, now there is a triangle which you need to be knowing about in order to solve values. So I'm gonna write that triangle. So suppose the angle making here is 37. The value which is opposite to the 37 always is going to be your 3, whereas this is going to be a 53. I think you have seen this values in your problems in JEE, NEET and all those competitive exams. The value opposite to 53, the side length, is always going to be your 4, and applying Pythagoras theorem, this is going to be your 5, and this is your 90 degree. So sine of 37 is going to be your 3 by 5, cos of 37 is going to be your 4 by 5. So whereas sine of 53 is going to be your, so sine of 53 is 4 by 5, whereas cos of 53 is going to be your 3 by 5. Whereas tan you can just do sine by cos, so remaining trigonometric values you can just come into conclusions. Now also what if I enlarge this particular triangle by twofold? Say I'm going to do this 6, this is going to be 8, and can you expect this value? Can you guess the value? Of course 10, because this particular triangle has been doubled here. So the 3 has become 6, 4 has become 8, 5 has become 10. So now the basic question which you're gonna get is, does the angle double also? No. These two triangles are similar, but as you know, in similar triangles, length are in the same ratio, whereas angles will be always same. So angles will be same here also. So 37, here is going to be 53, here is going to be my 90. Now what if I shrink this particular triangle by half? What if I half this triangle? So this value is going to be my 1.5, this is going to be my 2, this is going to be my 2.5. So this is the, and the angles also, this is going to be a 37, this is be 53, and this will be 90. So the main triangle which you need to remember is only this, and rest of the ratios. So suppose x, I'm going to write simply x. If you multiply x by 2, you're going to get this triangle. If you multiply x with 0.5, you're going to get this triangle. Similarly, you can create thousands of different triangles from this particular triangle. And this particular triangle is very important because many problems in your JEE and NEET will be asked based on this particular triangle. So also the values should be remembered. I'm going to teach how to remember also. So you have sine 37. Since you have 3 over here, the numerator should be having 3. And the other thing is 4, so 53 means 4, obvious. Whereas cos, it is going to be reverse. So cos 37 will be the value of this, whereas cos 53 is going to be the value of this. So these were the few tricks which you need to be knowing before going into solving problems in physics as well as in vectors. Okay, now let us discuss a few problems on resolution of vectors. So the first one given is written on the board. So a vector is 2 I cap 3 j cap plus 4 k cap, whereas b vector is 4 I cap 3 j cap plus 2 k cap. We have to find a plus b and a minus b. So as I told you, you can perform operations on the components of vectors. So a vector plus b vector is going to be just sum of respective components. So 2 plus 4 I cap plus 3 plus 3 j cap plus 4 plus 2 k cap. Now simplifying this, 6 I cap 6 j cap plus 6 k cap. Also you can write 6 I cap plus j cap plus k cap. So now solve the next one, which is a minus b. Is simply just subtracting the respective components. So 2 minus 4 I cap plus 3 minus 3 j cap plus 4 minus 2 k cap. So subtracting this, so minus 2 I cap plus 0 j cap plus 2 k cap. So this is the addition subtraction of a minus b vector. So this is how you're going to do addition and subtraction of two vectors if the components are given. If the components are not given, just go for geometric method, which I taught in the first part. Okay, now let us solve the second one. So this is the first problem which I chose to show you. So the solution is given here. It's this long, still here. So I'm going to teach how to solve this in a very simple manner. So they're saying the resultant of a vector, b vector plus c vector, the resultant means sum of all these three vectors is 0. We have to find the magnitude of c vector as well as b vector. Now the magnitude of a vector is given, which is equal to 5 meter. So now let us write it over here. So magnitude of a vector equal to 5. So simply I'm going to write it as a, and for this I'm going to write it as c, this as b. Now first thing what I need to do is I have to resolve c vector. So as I told you, you can resolve it along x and y axis. So this is going to be my cx and this is going to be my cy. So as you know, cy is equal to c sine theta, whereas cx is going to be my c cos theta. Now since these two vector cancels out and give your resultant as 0, I can say that c cos theta should be equal to b. So I can say that, so this vector should be equal to this, which means the magnitude should be equal. So c cos theta should be equal to b. Similarly, if these two are equal, these two vectors are equal, then only the resultant should be 0. So from this I can also say that c sine theta, so c sine theta should be equal to a. Now what is your theta value? Theta value is given as 45 degree. So c cos 45 is equal to b, c sine 45 is equals to a, and your a is equal to 5. So c into c into cos sine 45 is 1 by root 2 is equals to a is 5. So c is equals to 5 into root 2 meters. So similarly applying here, so c into cos 45 is 1 by root 2, whereas c you got your answer as c is 5 root 2, which I got from previous answer. So into 1 by root 2 is equal to b. So these two cancels. So your b is going to be 5 meters, and c is also going to be your 5 into root 2 meters. So this is how you're going to solve using this particular method. So now let us solve the second problem. So you have a point over here, and on this point you have three particular tension forces, which is TA, TB and TC, and the angle between this and TB is given as 37 degree, and the acceleration of this particular point is given as 0, which means this particular point is in equilibrium. So I can say that the resultant of these particular vectors is equal to 0. So first conclusion is resultant equal to 0. So if acceleration equal to 0, which means resultant equal to 0, which means net forces equal to 0. We have to find TA and TB. So for that I have to resolve TB vector. So TB vector, if I resolve along x-axis, so TB cos theta, I told you if you want to write along horizontal component, it is always going to be your this vector into cos theta, whereas along vertical it is going to be TB into sin theta. So since it is in equilibrium, I can say that this vector is equal to this vector and this vector will be equal to this vector. So let us come into conclusion. So TB sin theta, so TB sin theta equal to TC, so TB sin theta equal to TC, so TB sin 37 is equal to 300, so TB sin 37 is 3 by 5 is equal to 300, so TB will be equal to 500 newtons. So see, we were able to solve this particular problem very easily using resolution of vectors. So now let us find the remaining TA. We found TB. Now let us find TA. So TB cos theta. So this vector should be equal to this vector in order to be in equilibrium. So these two vectors also equal. So TB cos theta should be equal to TA. So TA equal to TB is, I found it as 500 Newton, and cos 37. So cos TB cos 37. So cos 37 equal to 4 by 5. So 5 ones are 500 ja. So TA is equals to 400 Newton. You could have also guessed this using the triangle which I showed you in the beginning. So that the triangle is this 37, 3, 4, 5 triangle. So similarly, you can also conclude that since this value we found as 500 and the downward vector is 300, you can easily say that remaining vector, which is the horizontal one, should always be equal to 400. So this 400, whereas this vector is 500 and this is equal to 300. So these are the few tricks which you can use in order to solve problems easily. So let us solve the last problem. So you have a block. So two people are pulling the block in this direction as well as in this direction, which is making an angle of 45 degree from the x-axis down and below with the force of 2000 and 2000 Newton respectively. So we have to find the resultant force. So first thing which you have to do is resolve this particular vector. So you have this vector, so along this axis, so say let us f is equal to 2000. So f cos theta and this will be f sin theta. So your value is going to be, since force is 2000 Newton, so 2000 into cos 45 is 1 by root 2. So 2000 by root 2 Newton. And this is also going to be your, so I'm going to do that, f sine 45, that is equal to 2000 into 1 by root 2, 2000 by root 2 Newton. So these two forces are equal, which is equal to 2000 by root 2 Newton. So similarly, if I resolve this particular vector, my component of this is going to be your 2000 by root 2, whereas this is also going to be 2000 by root 2. So I'm going to write everything separately. This force, we found it as 2000 by root 2 Newton. This force is also 2000 by root 2 Newton. This is also 2000 by root 2 Newton, whereas this force is also 2000 by root 2 Newton. So resolution of this vector is going to be these two, resolution of this vector is going to be these two. Now since these two vectors are equal and opposite, I can cancel these two vectors. So these two vectors simply vanishes by cancelling out. So these two vectors are out. Now these two vectors are remaining. Since they are in the same side, I just have to add them algebraically. So 2000 by root 2 plus 2000 by root 2 will be equal to 2000 into 2 by root 2. So 4000 root 2. So my net force is going to be 4000 root 2 along the x-axis. So this is my resultant vector magnitude. So magnitude of resultant vector is going to be 4000 root 2 Newton. And the direction is along x-axis. So this is how you make problems extremely easy and solve them using resolution of vectors. So this was the end of the video. I hope you understood everything which I taught today. If you learned something new, make sure you subscribe to my YouTube channel and just let me know whatever the topic you want me to teach in the comments. So I'm going to meet you in the next video. Thank you.